All right, let's talk about something that's absolutely critical, but honestly, doesn't get talked about enough when building AI apps. How do you make them bulletproof? Let's dive right in. So picture this. Your app's running great, users are loving it, and then, boom, an API call times out. What happens? Does the whole thing just stop? Answering that one question is what separates a cool demo from a professional, rock-solid system that people can actually rely on. Now, what if you could take that system, which feels a little fragile, and bring its failure rate down to less than 0.1%? That's what we're talking about today. It's a completely different way of thinking. It's not about trying to stop every single error. It's about building a system that just expects them and knows exactly what to do. And let's be real, this isn't some theoretical what-if scenario. We're seeing that AI systems out in the wild have a raw error rate of somewhere between 1 and 5%. So failure isn't just possible, it's a flat-out guarantee. The only thing you really have control over is how your system reacts. And that's where this whole idea of a reliability playbook comes in. This is our big mindset shift for today. We're moving away from the impossible goal of preventing every single failure, and instead, we're designing a system that can handle them gracefully when they inevitably happen. So, what's in this playbook? It all comes down to fallback and error handling. Think of it like having multiple layers of defense. First, you gotta spot the problem. Then, you try a quick retry. Maybe that doesn't work, so you fall back to a simpler model or even a pre-saved answer. The goal is always the same. Make sure the user never, ever sees a nasty technical error message. And this playbook is really built on 4 core layers. First, you have to know what kind of error you're dealing with. You classify it. Then, for the temporary glitches, you retry. If that fails, you have your fallbacks ready to go. And finally, you have a master switch to protect the whole system from a domino effect. Okay, let's peel back those layers and really get into the details of how these 4 strategies work together to build something incredibly resilient. So why do we need all these different defenses anyway? Well, just look at the kinds of errors that actually pop up. A massive 40% are just from hitting API rate limits. Another 30% are vague server errors. Then you have content filters and timeouts. The point is, there's no single silver bullet because the problems themselves are so different. And that brings us to the first and maybe most important step. You've got to classify your errors. You basically need 2 buckets. In one bucket, you have transient errors. These are the temporary hiccups, like a rate limit or a busy server. They'll probably go away on their own, so the right move is to just wait and try again. But in the other bucket, you have permanent errors, like a bad API key. Retrying that is totally useless. For these, you need to stop immediately and go to your fallback plan. Now, let's talk about retries for a second, because they're a simple idea with a huge impact. Done right, they can automatically fix 60 to 80% of those transient errors. The secret sauce is something called exponential backoff. You don't just spam the server. You wait 1 second, then 2, then 4, giving it a chance to breathe. And here's a pro tip. Add a tiny bit of random jitter to that wait time. That stops all your failed requests from trying again at the exact same time, which can make things even worse. So what happens when retries don't work, or you hit one of those permanent errors? That's when your fallback hierarchy springs into action. This is all about degrading gracefully. You start with your best model, say GPT-4 Turbo. If it fails, no big deal. You just try a different one, maybe GPT 3.5. If that also fails, hey, do you have a cached answer that's close enough? No? Okay, let's try a much simpler prompt. And if all of that fails, you have your final safety net. A simple, helpful message for the user. The system never just dies. The last layer of our defense is the circuit breaker. This is your system's emergency brake. Imagine an API you rely on is having a total meltdown. Just retrying over and over is pointless. So, a circuit breaker watches for this. After, say, 5 failures in a row, the circuit trips and stops sending requests for a minute or so. This does 2 things. It gives that service time to recover, and, more importantly, it stops one broken part from taking down your entire app. Okay, enough with the theory. Let's make this real. Let's see what this transformation from a brittle system to a resilient one actually looks like. Just look at the night and day difference with a simple retry strategy. The brittle approach on the left, any little API error and the whole thing falls over, showing the user some ugly error code. But the resilient approach on the right, it just automatically retries, using that smart backoff and stays up and running. The user might feel a tiny delay, but they never see the system actually break. And this is where it gets really powerful with fallbacks. The old, brittle way depends on just one model. If GPT-4 is having a bad day, your feature is just gone. The resilient system, though, it has that beautiful hierarchy we just talked about. It tries one thing, then the next, then the next. It gracefully degrades, making sure it can almost always give the user something useful. That is what reliability looks like. Okay, let's wrap this up and turn it into a blueprint you can actually use to get your own systems ready for the real world. First up, let's talk about what not to do. The big one, don't retry permanent errors. It's a waste of time and money. Always have a maximum number of retries, or you could create an infinite loop. And don't forget that little bit of random jitter. Finally, please never rely on a single point of failure and never show a raw error to your users. These are the telltale signs of a system that's not ready for prime time. And really, if you take away one thing, it should be this idea. A response that's a little bit slower, or maybe not quite as perfect, is 1,000 times better for the user than a screen that just says error. That mindset shift is everything when you're building systems people can actually trust. And the result of all this work? It's huge. When you put these patterns together, the classification, the retries, the fallbacks, the circuit breakers, you can realistically push your uptime to 99.9% or even higher. Your app goes from being a fragile experiment to a dependable tool. So I'll leave you with a question to think about for your own projects. Right now, is your AI built to fail the first time something unexpected happens, or is it truly built to last? Now you know how to make sure it's the latter.